In this session, I'm going to talk about one of the crucial aspects in marketing analytics, which is the principal component analysis. It's not a hardcore marketing concept, right? It comes from the world of matrices and has its applications across in wide variety of areas. But definitely in marketing analytics, it is used quite heavily. So, as an agenda here, I would be talking about how do you really do an initial data setting if you have to perform a principal component analysis on your data. So, what does the principal component analysis typically do? Right, we'll work with a brand rating kind of a data, and based on that, let's try to explore what can PCA do for us in this particular context. So, what are the various functions? What are the various packages of R that I can use to perform this principal component analysis? How do I really interpret the output that is given by R on this principal component analysis? Then, talking about the visualizations, once the PCA is performed, how do I visualize the PCA? What are the kind of graphical representations or the charts that I can very well create with respect to the PCA? And finally, I want to talk about what are the kinds of steps that I really need to take or make sure when I'm executing my visualization. One of the major visualizations of the PCA is the perceptual map. So I really want to look at what all things I can take care of when I am doing this kind of perceptual maps and a PCA analysis. Generally, when we talk about a marketing data set, there will be many variables. You might be having variables relating to the satisfaction levels of the customers regarding the various brands, products, so many other things, right? Service, or we can talk about in which areas a particular brand is a leader, in which area the particular brand has to improve, areas of improvement. So there are many aspects of a particular product, brand, etc. that we would be capturing. So if I have so many variables, analysis will be a much difficult aspect. So the main requirement for me in these contexts when there are multiple variables is try to group these variables into similarities and see, can I work with a reduced set of these variables? Can I group these questions together? Can I group these responses together? And based on that, can I reduce the number of variables to a smaller subset? The moment I am able to reduce them, that is what will give me a kind of a possibility where I can identify the relationships among the various concepts. So when I have 20 different variables, I cannot understand the broad relationship between the variables. But if I am able to reduce these 20 into 3, by trying to group these 20 into 3 different components or 3 different groups, I can very well assess the relationship between these three quite comfortably. Now that is what is the major intention that I am talking of here in the context of the marketing variables. And to accomplish this, we have various practices, but of course the most common ones are the principal component analysis, the exploratory factor analysis EFA, and multi-dimensional scaling MDS. All three are core marketing applications. They have a lot of applications in the world of marketing where there are multiple variables. PCA, what it typically does is it tries to remove the interdependency between the variables. See, when I'm talking of 20 variables, in reality, these 20 variables may not be independent at all. Right? There will be some level of correlation that is existing between these 20 variables among each one of them. So the intention of the principal component analysis is remove that correlation. And the way it removes is it creates linear dimension. So these 20, they become some linear combination and forms one new component called C1. Similarly, again these 20 come together in some other combination, form another component called C2. So like this, a few components, like 3 components would be formed here in such a way that the correlation between C1, C2, C3 is literally 0. And C1 is some linear combination of these 20 variables. C2 is another combination of these 20 variables. C3 is another combination of the 20 variables. And they are computed in such a way that the dimension captures the maximum variance in the data. Right? So component 1 tries to capture whatever is possible, the maximum variance, whatever it can capture in one single component, it can take care of that entire thing. Then whatever is left, again to whatever extent it is possible, the component 2 captures the maximum possible out of the remaining, like that C3, C4. So that's where we find the first component captures a much bigger proportion of the variation in the original data. The next is captured by the component 2, then component 3, and so on. So when we execute it in detail, you'll get much more clarity of it. Similarly, apart from principal component analysis, another major analysis that can help us in reducing the dimension of the variables is the exploratory factor analysis, which also captures the variance, small number of dimensions. So I'm reducing the overall set, but the dimensions are typically getting interpreted in terms of the original variables itself. Here it's a linear combination of the original variable, whereas in exploratory factor analysis, we are interpreting the dimensions in terms of the original variables itself. We will talk about it in more detail when we are executing it. Similarly, the third thing which can bring out a reduced set of variables is a multidimensional scaling, where the similarities among the observations are typically mapped. So in terms of the low dimension space, the similarities among the observations are typically mapped. Again, when we take up examples, it could be much more comfortable for us. So with this, we will get started, right? Wherein we will look at the principal component analysis by taking a small data set in R. So we will look at the brand perception. So there is a survey. I have a data that is relating to a survey regarding the brand perception. So on various counts, on various headings, these brands have been surveyed by the customers, surveyed from different customers. So we are trying to capture that entire details and we are trying to really assess them. So on different aspects, on different headings, where are each of these brands? So let me just look at the data accordingly. Right, this is the data I'm talking of. I have a brand rating data. I'm reading it into a variable called brand. Right. So I'm looking at the dimension of the brand to see how many observations I have. I have 1000 observations regarding different brands and 10 variables on which each of these brands are questioned. Let me look at the structure of the brand to understand it much more detail. So the data frame, 1000 observations are there. So I am capturing something in terms of the performance of the brand. So the performance, so is my brand performing well? Is this brand having is a leader in terms of performance or not? So 1 is the least and 10 is the highest. So leader, is it a leader in that particular field? So 1 is the lowest versus 10 is the highest. So does the brand have latest products? Again 1 to 10 scale. Is the brand is more and more of a fun, or is it more and more of a serious? So I can I really get these products of this brand at a much cheaper prices? Are they good value for money? And is it trendy? Is it more reflecting the current scenario? And is it that I would rebuy this brand again and again? So these are the different kinds of questions that I have put to the customers, and based on the responses they have given, we are looking at different kinds of brands: A, B, C, D, E, F, G, H, I, J. So there are 10 different brands, as we could see here. So that is what is. So we are trying to evaluate the brand on these 9 different dimensions, and probably if you look at overall there are 10,000 observations. Probably I would like to take the table to see, is it like 100 observations for each brand. So this is where I want to take the table of brand dollar brand. Brand is my data frame, and the brand is my variable as well. So yes, from A to J, I think 100 is the table. So 100 customers are typically surveyed on each of the brands in all these 9 dimensions, right? So these are the ones that we typically have. So we can look at the head of this brand, by where I can get the first few values. So on the performance, someone has given 1 to 10 kind of a scale: leadership, leader in that particular space, is it having the latest products, etc., etc. So this is what we have, and we can observe some of the variables here. We have looked at the summary as well. If I want, I can have a quick look at. These are some of the initial checks which we should perform always. So performance wise, yes, there is a minimum of 1, maximum of 10. Median is 4, first quartile is 1, third quartile is 7. Leadership also similar, latest also similar. So this is the typical data that we are looking at. Fun is also similar, right? The median values, bargain values, etc., etc. So this is what is provided by the summary. So all numericals. All these ratings are appearing to be numerical, and I could see that the brand is formatted as a factor, right? All are integers. The ratings are taken as integers and the brand is taken as a factor. So this is what is my initial data. Once I have my data, the first step is I have to rescale the raw data. When I'm saying rescale, it makes the data more and more comparable across the individuals and across the sample, especially if my data is having different sizes. So here any of all the variables have a 1 to 10 kind of a scale, so more or less the size is similar. But in some cases, let's say if one variable is the rating like this 1 to 10, and the other variable is amount spent on that particular brand, and probably it could be in a few thousands or something. So one variable is just a 1 to 10 kind of numbers, whereas other variable is in thousands. In that case, comparison becomes more and more difficult. So this is where, when your variables are having completely different kinds of sizes, the first step we do before executing a principal component analysis is we try to scale the data. So this is what we typically call as standardizing the data, or normalizing the data, or z-scoring the data. There are different terms used by the people in different contexts. So we can very well do any of these aspects on that particular brand. So probably I'll call as brand scale. Right, I'm taking another new variable called brand scale. Brand, let me keep it as it is. So I'll take the scaling of the brand, but I'll not take all the columns. Probably I'll remove the 10th column, which happens to be a factor variable. So let me not do any kind of scaling on that. All the remaining things I'll do a scaling. So I'm taking all the rows, but columns wise I'm omitting the 10th column. And I'm computing the scaling for each one of them. So if you look at the head, I could typically see, so this is what is typically being contained as a part of the brand scale, and I can look at the dim of brand scale. It is 1000 rows and 9 columns. Now I require the brands also to be appended. So what I can do is I'll bind to this, right? So let me bind brand scale, let me call it like this. I'll do a C bind where I'll take the original brand scale, but to it I will also add brand $brand. I'll add the brand column from the brand data frame so that I'll have a capture of the variables. So now if I look at the head of brand scale, I'll get it like, okay, here I'm getting the brands as 1, 2, right? So I'll look at the tail of brand scale. It gives me 10, right? So I can very well do a C binding of that, right? Or probably let me omit, right? Let me again redo it. Brand scale, I'll remove the 10th column. So I'll say brand scale, all the rows, remove the 10th column again. So now when I'm again rechecking the brand scale, it is again only up to here. But let's say I want to look at look at we will try to add the brand, right? I'm simply taking all these columns, but let me add the brand names. How do I add it? A B C D. So let me look at what is there as a part of brand and brand. So let me look at head brand $brand. What is there? Yeah, it is A B C D E F G H itself. So I can put the row names directly. That should be better. Row names of this brand scale. Right, let me try this. Row names of brand scale. Let me set it as brand $brand. If I set it like this, how am I going to get it? So when I'm setting row names of brand scale, so let me now look at how the brand scale is coming, because I have set the row names to this. Now now it is coming out as A. So the brand name, the row names are coming out more like this. and but this is not a column. But if I'm trying to add, okay, that's okay, we'll come back to it. Now once I have this scaled data, I can very well look at the intercorrelation. Okay, so now that I have scaled the data using this, I could see that the mean is 0 across all the variables. Let me do a summary now of the brand scale. When I do it, I could see that the mean is 0 in all the cases because we are subtracting the mean and dividing it by the standard deviation. The mean is 0 always. Then the next step that I am looking at is I am looking at inspecting the bivariate relationships between the variables. And the bivariate relationship I can very well examine using the correlation plot. Right, or core plot dot mix, whatever it is. So I can go with a core plot or core plot dot mix. So we have already looked at it earlier. So I'm simply loading the core plot package, and in this I can use core plot dot mixed or core plot, whatever is the formula. For that I have to provide the input. Right, the input that I have to provide is the correlation. I can give a brand scale as an input. So I want to take the correlation with respect to the brand scale. So let me see if I am getting the correlation with respect to the brand scale. This is what it is happening. Right, the blue ones are positives and the red ones are negatives. So now I could see that this one, performance versus leadership, there is a good positive correlation. Similarly, here I could see seriousness versus leadership, then probably latest versus trendy, then bargain versus value. These are all looking highly positive, whereas value versus trendy is looking negative. The red ones are on the negative side. So I could see this is how the correlation is typically coming out, right? So I could see some of them are more and more similar. Some of them are quite different from the rest. So we can really aggregate the things which are very close to each other. So probably the same correlation plot, if I do the ordering, right, the same correlation plot, if I do the order equal to H cluster, which is a hierarchical cluster, the order will be slightly different, which can really help us in seeing which all the things are close to each other. So probably the fun, latest, trendy, these are all are looking more or less on a similar lines, because you could see that they are correlated more or less in the same way with the rest. And I could see similar things with respect to rebuy, bargain, value. They all are carrying similar kind of scenario. So they are all more or less in this range. So the ordering can give us different kinds of patterns from the data. Performance, leadership, seriousness, they look like they have quite a good amount of correlations and the interactions between them. So all these things become more and more easier when I am doing a H-cluster based ordering of my correlation plot. And if required, sometimes I would typically look at, instead of taking it on the raw data, I don't mind taking this from the data which is aggregated. So let's say instead of taking the overall ratings, I can take a mean rating for each brand, and based on that I can typically assess the kind of correlations, right? So let's say brand mean. is the new variable that I want to take. Alright, wherein I can talk about right from the original itself, aggregate. I want to take the aggregate. I want to take the aggregate of all the variables across the brands, right? I'll use the brand data. I want to take the aggregate of all the variables across the brand where the data that I am considering is the brand data frame. So from that data frame, I want to aggregate all the variables based on the brand, and what I want to compute is the mean. So from here, I'll get a head of my brand mean. So I've got brand means are this much. So I can very well make this as the row headings again. So row mean or row names of this particular brand mean, instead of A, B, C, D, I'll set the row names as brand dollar brand. Right? I'll set the or probably I'll set brand mean dollar brand. So from the brand mean itself, I'll take the brand and that I'll set it as the row name. So instead of 1, 2, 3, 4, I'll have A, B, C, D kind of stuff. So I can very well get, now if I want to look at the brand mean, let's say let me take brand mean, I'll simply get 10 rows, A, B, C, D, E, F, G, H, I, J, and all these are the averages on all these different counts. If required, now I can even remove the brand. So brand mean, I'll simply call it as brand mean of all the columns minus 1. I can remove the first column now. So now my brand mean will become just performance, leadership. So these are the different kinds of values that I can get. So this is one way I can do it either on the, now if I try to look at the same correlation plot, right, core plot mixed, let me bring in the core plot mixed now. Instead of brand scale now, let me do it on brand mean, the average values. So this could be the kind of relationships that are occurring. Again, you see fun, latest, trendy, they are in this order, rebuy, bargain, value, or in the different order. Perform, leadership, seriousness, they are looking more and more closer to each other. So even if I am doing it on the brand, on the mean value, I'm getting more or less similar kind of structure, right? Now, the next thing I'm looking at is I can even go ahead by performing a kind of a heat map, right? Heat map is typically used to examine the results. It's there as a part of the gplots package. So I can install the gplots package to look at the heat map. So the gplots package right, if required on the top of this gplots, if I want some kind of a color coding etc, I can use color brewer kind of packages. But otherwise, if I am more interested just in looking at the gplot, that is what I would like to show now. I'll take a simple library of gplots. Right, this package is built. This has a function called heatmap.to. I'm actually able to generate a heat map, but this heatmap.to requires the data as a matrix, not as a data frame. So that's where I'll convert as dot matrix. I have a data frame which is brand mean. So I'll convert it into a matrix. Anyhow, it's all numerical values. So because I wanted to look at the heat map, I have made it numerical values. I have converted it into a matrix. So once I look at the heat map, this is how I am getting the heat map associated with each of these variables. So the color history is coming from all these dimensions. So the values. So this is a much better way to segregate the data. Right here we are seeing from red to yellow kind of a typical transition, right? Red color is indicating low values. So wherever the things are more and more red in nature, I'm getting a lower values. And wherever the green, yellow is typically present, it indicates a high value. And if you are looking at a mix of those two, it's more of something in the middle. So now when I look at the different brands, A, B, C, D, all these different brands, so there are some brands that are rated very high on the leadership and performance, the ones that are showing more in yellows. So I could see that the brand BEC is much yellow with respect to leadership and performance. Right, in leadership also brand C and B are looking more yellow. So which is an indication of very strong in terms of leadership and performance. But let's say I am looking at brands F and G, these two. They are looking much yellow in these 2-3 areas. Bargain is much yellow for F and value is also much yellow for F. Similarly, if I am looking at A and D, I could see that they are much yellow with respect to the latest. So they are the ones that offer the latest kind of products. So we have a different way of looking at the overall branding altogether. Right? This is how the clubbing is also happening. I and H are looked at similarly. First A and J are looked similar. B and C are looked similar. F and G are looked similar. Now, on the top of that, next I, J and H, I, H and D are looked similar. So you could see the kind of a matrix here, which are a kind of a tree structures here, which are showing which variables are together and which observations are together. So this is what can give us a kind of an high level overview where the entire sorting of the rows, columns is typically done, where you can understand the similarities, patterns in the data. And this is the most important visual inspection that we can do when we are evaluating our data at the beginning. So this is an indication that some variables can be grouped across some of the observations. So this is one major reason why we are typically looking at the principal component analysis, because there is some level of interdependency that I am seeing across different variables, and I want to explore that in much more detail. Right? So that's the major starting point for us to get started with the principal component analysis. So if the data is not in the form of a matrix, if I have to use a heat map, I have to convert it into a matrix. And if at all I have a color brewer or color brewer package, I have many more options in terms of setting the colors. But by default, the sorting is typically done in order to emphasize the similarities and patterns in the data. And based on that, the groupings, relationships can very well be understood. This is what I was talking of as an interpretation from this heat map. We can quite comfortably interpret the groupings as well as the relationship between the variables. Now understanding the principal component analysis from this particular data. Now based on these variables, here I have a 9 set of variables for this example. Right? Based on these 9 variables, PCA is computing different sets of variables, let's say PQR, three different sets of variables, which are the linear combination of these 9 variables, which we are calling as the components. So the linear relationships in the data is what is typically captured as a part of PCA. The first component captures as much of variance as possible. Whatever is remaining within that, as much of variance as possible is captured by the second component. And the major objective of using this entire exercise is it reduces the complexity of the data and trying to have more or less the entire variance of the original variables, but with a very small subset of the new set of variables. So only subset of those components are typically used, but overall variation is retained to a much larger extent. So these few components, select few components that we are going to go with, they will explain a large proportion of the variation that is present in my data. That is one of the major advantages of using the principal component analysis. So we are using right now for brand ratings, but possibly if I look at the different applications of it, I can use the same concept for rating my products, right? For positioning my segments of customers, I can rate the political candidates, I can evaluate the various advertisement campaigns. The major part to look at is I have different metric data that is available in multiple dimensions. So multiple variables capturing the data regarding a very few amount of discrete entities. So I have taken the brands here. Rather than that, I can look at the consumers or segments of the consumer or the products or the candidates, advertisements, all these things where I can aggregate on a multiple dimension variables. I can use this concept of principal component analysis. So we can do the principal component analysis for our data and better see what kind of interpretations we can do by using this principal component analysis, right? Now, if I have to look at working with the PCA, the next thing that I can look at is I can use this function called PRComp, which will give me the principal component. This is there as a part of the base R package itself. So this will identify the principal components from the variables. So depending on whether I am going with the mean data or I am going with the original data. So let me first go with the original data, then I'll go with the mean data, right? So initially let me do a plotting of it's better I get the correlations which we have already got, right? The correlations, if I can try to get between for the brand scale, which is my original data itself. So you could see that there is some correlation of zero point 0.5, there is some 0.57, so there are some positives, there are some negatives kind of correlations between the variable. So which means it is very much, it's very much evident that there is some level of interdependency between the variables, right? Which means there is some necessity for me to do this principal component analysis. That's the starting point for me to understand the principal component analysis, right? I really want to look at what is the level of correlation that is existing between the variables first of all. If it is more or less existing, then it's better that I do a principal component analysis on the data. So I'll call it as brand scale PCA. Now I'm doing a PCA on the brand scale. So this is where I'm using my function PRComp. PRComp is a function that I'm using on the brand scale. So this is the simple function that I can use. Right, that's it. My principal component analysis is typically executed. I can do a simple summary of the brand scale to evaluate brand scale PCA. I'll do a simple summary of the brand scale PCA. So I could see that the PC1, the standard deviation is this much, proportion of variance, almost 33% variance is captured by the first component itself. So here we have got 9 components. So across all the 9 variables, the components are typically being distributed. Right? I could see now the first component is talking about 33% of the overall variance in my variables is captured by the first component. 23 is captured by the second, almost 12 is captured by the third, 8 by the fourth, 7 by the fifth, 5.9 by the sixth, 4.3 by the seventh, 3.4 by the 8th and 2.7 by the ninth component. So this is one thing, the first thing that we look at. So probably I could see that the first 2 components alone capture almost 56% of the total variation, and probably if I'm bringing in the third one also, it's almost 70% altogether, 68, 69, 70% altogether. Now this is where I can look at my the actual object. So I'll do a brand scale PCA as an object. This is where I would look at the rotated component matrix. So the rotated component matrix typically says PC1. Within the PC1, there are a few positive components. So the PC1 is a much significant kind of a component. In that I could see that trendy, latest and fun, they have a negative relationship, whereas all others are having some positive values. Whereas in case of PC2, I could see fun, bargain and value carrying a negative numbers. Serious, leader, they are all more or less similar. They are carrying similar kind of values, right? And in PC3, if I could see, only the performance is looking different from the rest. I could see big negatives in the case of latest, fun and bargain. So we could see each of these components, they have a different kinds of loadings, right? There is a multivariate nature that is coming into this PCA. So at this moment, interpreting the PCA output is not that easy. But before that, I should do a plot for my PCA. I'll do a plotting for my brand scale PCA, which will give me this. If I'm doing a brand scale PCA, this is actually a kind of a scree plot. This is what we call, right? It talks about the successful proportions of the additional variance that each component adds. So I can very well plot it like this, or I could have plotted it as type equal to L, which means a line chart will be plotted. So this is the traditional scree plot. The scree plot talks about successive proportion of additional variance. So this one is having this much of variance, then it is adding this much of variance, the second component, the third component is this much, the fourth component is this much, and so on. So where the additional components are not worth the complexity, where you are seeing a kind of a kink, it's better to stop at that particular point. Here I could see that right from the fourth component, there is a kind of a flattening that is happening. So where the line has a kink in the angle of bending, So I could see some kind of a flattening kind of stuff that is coming out. That is an indication that beyond three components, the kind of value addition that I'm getting is much lesser. So I can look at the summary of the extracted principal components, which is what I have looked at here, which talks about the first three components contributing quite heavily. Probably the first two have contributed much heavily. The third is moderate, but from the fourth onwards, the component contribution is much lesser. Then I can look at the rotated component matrix. That is what I am seeing here. It's not that easy to understand and interpret the rotated component matrix from the PCA, but at a later point we will see factor analysis is much a better aspect, a better scenario to talk about when we are trying to interpret the PCA. Compared to interpreting the PCA, factor analysis looks more and more comfortable. But a few things that we can look at is the signs. PC1, I could see that leader, fun and trendy, they are behaving differently compared to the other ones. So latest, fun and trendy looks slightly different. Whereas in the next one, fun, bargain and value are looking differently from the rest. Whereas in the third component, it looks like perform is looking different from the rest. So because these are the three main important components, and in the fourth one it looks like perform, leader and rebuy are along with fun, they are looking different from the rest. So a few such kind of sign related variances is what I could typically see in the variable. But the more important thing than this is I can look at the scores for each of the principal component. So this is how the principal component got created. I can say brand scale PCA $X. This will give me the kind of the way in which this entire function got computed. Right? This is my PCA $X, which talks about the way each of these values are typically computed. And this is the coefficient matrix. Probably if you look at the structure of brand scale PCA, you will be able to identify what all it gives. One, it gives me the standard deviation. It gives me the rotation, which is a rotated component matrix. It gives me the center. It gives me the scale. It gives me X. X is nothing but the components. If it had typically computed the component, what are the values that are associated with each of these components? So based on these components and based on the original data, it computes the values, and that is what is the typical values that we are getting for all these 1000 observations. And if required, if I look at my correlation that is existing between these observations now, right, between these 9 components, so I'll call brand scale PCA. If I look at the brand scale PCA $X, which are my 9 columns of data, I could see that the correlations are almost zeros, which means there is no interrelationship that is existing between the variables at all. That's the most important aspect when we are talking of a principal component analysis. And so that is what we are talking of. Extracted PCA components are uncorrelated with one another. I could have checked it with the correlation function. They are all showing perfect zeros, which means there is no relationship that is existing between the principal components that are extracted. Then the other thing that we talk about when we use the principal component analysis is the visualization part, where I may typically want to evaluate the two components, let's say PC1, PC2 and PC3. The first three components I really want to visually examine. So one of the things that I can do is a biplot. Biplot is actually plotting between two variables, two components. So in this case, it plots between component 1 and component 2. So I do a biplot where I'll call it as brand scale PCA. So this is how the the biplot typically comes. If I explore this biplot a little bit more, I could see that the fun is in one dimension towards one side. Rebuy, value, bargain, they are towards very close towards each other. Latest and trendy are in one dimension. Serious, leader, performance, they are in one dimension, and probably rebuy is in one more dimension. So these are the typical, so you could see the rebuy more and more parallel to PC1, right? So that's one more aspect I could really look at. So this graphs and the arrows which we are doing is between PC1 and PC2, which can really help me when there are smaller number of points or when there are clusters. So here the points are too many, so visualization is not that easy. But what I can do is I can do this similar kind of a biplot for my mean data. So I already have a brand mean, right? Some variable which is talking about the mean. So I have already have the variable called mean. So what I can very well do is brand, right? Let me call it as brand mean PCA, right? Let me do a PCA on the mean values. So I'll first do a PR comp on brand mean. But first of all, I need to do a rescaling because mean need not be a scaled value. So I can't directly keep it as it is. So I don't want to I don't want to take the values as it is. So it's better that I rescale them. So this is where I can set, when I am using the PR comp, I can set scale equal to true. By setting a scale equal to true, there is a rescaling that is typically happening. So I am able to rescale it now. So if I do a summary of brand mean PCA, now also it says, now the story is slightly different. If I am doing it on the mean, the first component alone is capturing 50% of the variation. The second component is 33% of the variation. So when I am doing it with a slightly small data set, it looks much interesting, right? The PC1 is having almost 50% of the total variation, PC2 a 33%. So first two components itself are constituting almost 84% of the total variation. So the other 7 components will become completely negligible. Even when I am doing a scree plot for this, I could clearly see that brand mean PCA, if I am taking a scree plot where I am setting my type equal to L, a line chart, I could see that after 2 components, I could clearly see that there is a kind of a flat. So here the first 2 components are itself sufficient for me altogether when I am doing it on the mean values. And even when I am doing a biplot on the brand mean PCA, I could clearly see, yes, fun is in one direction, bargain and value are in one, latest and trendy are in one direction, rebuy is in one place, perform, serious, leaders, right? So these are some of the things that are coming out as a part of the biplot. I could clearly see The categories like seriousness, leadership, perform, they are in one dimension. Value, bargain, and some extent rebuy, they are in one. Trendy and latest are in one, and fun is in the other direction. So, especially compared to the plotting the original data, if I am plotting the means, the graph is looking more and more interpretable. So I have used that aggregated values that we have done earlier. So based on them, we are creating the principal component. Now, this is what we are typically calling as the perceptual map, which talks about the different dimensions that are present as a part of the data. So the first two components, almost 84% of the variation in my variables, if I am going with the mean, if I am going with the mean values, right? So that's how we are looking at it. And even if you see the other way, when we have used the earlier graphing where we have taken the original data versus we have taken this mean data, I don't think there is any kind of a big difference with respect to the direction of the various variables, right? More or less, fun is always separate. Even in the earlier case here, latest and trendy are always in one single direction. So the typically more or less the interpretation remains the same. So we can typically look at the four major areas with respect to the various features, right? I could see brands B and C. They are very much high on seriousness and leadership. I could see brands A and J more towards fun. G and F are very high on the value aspect. So some such kind of things that are typically coming up. So probably there are different ways of interpreting this. If I am a brand manager for the brand E, it's almost in the middle. It is neither towards latest, it is neither towards fun, it's not in any of the directions, right? It's neither towards the PC1 or PC2, it's somewhere in the middle. So basically, I can talk about E as a safe kind of a brand. It's not anywhere towards any of the directions. So it's a relatively undifferentiated kind of a position. But if you want some kind of a differentiation, okay, fun-based differentiation, you have to move towards this side. If you want towards the leadership and trendiness, you have to move this particular side. Now this is where the brand manager for E might want to really evaluate where does he really want to position himself. So this is where one more analysis we can do from here directly. So if I am more and more interested in differentiation, I want to shift myself towards something. Let's say I am more interested in shifting my brand towards C. I could typically see where exactly I can improve. So for that I can typically compute the data. I'll take the brand mean with respect to the C, which I have given as a label, all the columns, minus the brand mean, I'll take it with respect to E, all the columns. So I'll typically see where all my E has to improve by what extent. So here, okay, this brand mean is untransformed kind of stuff. So probably I should take brand mean PCA $X, right? So let me take what is that we have taken brand mean. Okay, we have taken the principal components out of the brand mean and we have to scale. So let me take scale of brand mean. So let me call this like this. let me take scale of whatever is the scaled value of the brand mean. Out of that, I want to take for C minus the scaled value of the brand mean of E is what I would like to take. Yeah, so here it is coming out that when I'm comparing C versus E, the performance is C is much higher in terms of perform 1.77, so I have to improve on the performance layer. I have to improve on the leadership. Compared to C, I am much better as E in terms of latestness, in terms of fun. My E is much better compared to C. Seriousness, I have to improve. Bargain wise, I am much better off. So you could see in some cases where E is stronger, right? E is stronger than C with respect to fun. I could see E is much stronger, or with respect to value, right? Or with respect to bargain. I could see that C is E is much stronger compared to C. Similarly, on some areas, C is much stronger compared to E. So based on that, I could see if I want to be more and more closer towards C, what are the areas I have to compromise in what range compared to the other competitor brand. Or in some other case, I may look at completely not following any one of them, but probably going somewhere in the middle, right? I don't want to take this AJ route, or I don't want to take this GF route, but I want to position myself somewhere here. Wherever there is a kind of a large gap that is existing, I want to typically go in somewhere there, right? So this is where I can try to position myself. So which means I would like to play around with, or probably I would like to position myself in this particular area. So I can really look at positioning myself in those particular areas. So if that's the case, I can take the mean values of the areas which are surrounding the stuff, and I can see in which areas I have to improve versus in which areas I am already good at. So this is the kind of simplification, this is the kind of detailed analysis we would do when we are using the principal component analysis, with which we can really understand what are the dimensions in which my overall set of factors can be grouped, which can really help me in terms of understanding the relationships much better. So I think we have already looked at it. So the choices, okay, I can give the by plot, which we have already talked of. So I can interpret the clusters and the relationships much comfortably. So by default, the perceptual map plots the brands on the first two principal components, which clearly gives what is the kind of relationship that is existing between the various observations. So before we conclude this session, there are a few important things I want you to look at. I have to choose the level of aggregation and type of aggregation. Do I need to use mean? Do I need to use median? In some cases, median is a much better aggregation compared to mean, especially if my data is more and more ordinal. And in some cases, level of, okay, if how many factors do I have in my data? Do I need to do the aggregation across each of the factors? I need to be very careful in doing this kind of an exercise. Remember, the intention of the principal components is always to reduce the dimension of the variable so that I can really see where I am with respect to each of these factors. Check the dimensions, check whether the dimensions are similar for the full data and the aggregated data. So when I am talking about the dimensions, I am looking at both the raw data as well as the aggregated data. See that I can go with a biplot for both of them. So I have to really see that the dimensions of the data is more or less similar. The relationships are strictly relative to the product category. So even if I add one more additional product category instead of 9 variables, now if I add the 10th variable, or instead of 10 brands, now if I add the 11th brand or remove the one brand making it only 9 brands, there is a possibility that the whole positioning can change drastically and I have to rework. That's the one most important thing I want everyone to be aware of. Perceptual map is primarily based on the inputs that I have given. It's not a scalable kind of stuff where I can add one or two more variables or add one or two more brands and finally the relationships remain more or less the same. That is not the case. So this is where if you really want to assess the sensitivity of your PCA, do one thing, drop one or two variables from your data. Instead of 9, you run it with 8 variables only at a time and look at different samples. Probably take only a subset of your original data instead of taking all the 1000. Randomly select, let's say, some 70% of the data. Rerun this whole PCA analysis and look at your biplot every time. The more and more similar you are getting your biplot, you can bring in more and more stability to your interpretation. And one other thing that we have to talk of here is the strength of a brand on one single variable cannot be read directly from the chart. This is again a kind of a misconception. So whatever the positioning here in the graph, B and C being talked about here, it's not that they are strong on leadership or it's not that they are strong on seriousness. We are talking about two different components, PC1 and PC2. B and C are more or less similar on PC1 and PC2, right? It's not that they are strong on leadership or it's not that they are strong on seriousness. So the similarity is purely based on the relative values that they have on the two components, but not on one single variable. We have to understand that more and more heavily. This is a graph that is between PC1s and PC2. And the major thing is when I am looking at the largest magnitude similarities, I may ignore the smaller differences that are existing between them because here we are only looking at component 1 and component 2 and we are not going beyond that. So we have to really understand that that is a limitation that we are talking of. We are only looking at a big picture, but in the process we don't mind really omitting a few of the variables as well. So this example really gives a much better picture regarding the usage of principal component analysis in terms of brand rating. I could see different brands having leaderships in different kinds of aspects, which is where if I want to really position my brand which is in some other direction, what is the kind of effort I really need to make towards myself is what can be communicated quite comfortably using this perceptual map. So these are the various areas that we have already discussed as a part of this session. If you have any further queries regarding the same, you can very well get back to me by giving me a call on the number that I have given below, or even you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.